A constant voltage of 50 volt is maintained between the points A and B of the circuit shown in the figure. The current through the branch CD of the circuit is. So we have to find the current through the branch CD. Now the potential difference between A and B is 50 volt, and C and D are 2 points are short circuited, that is they are connected with a wire that has no resistance. So effectively the potential at C and D are equal, that is Vc is equal to Vd. So the potential difference between C and D are equal. So the potential at C and D is same. So the potential between the points A and C, that is VAC, is exactly equal to VAD, because C and D are the same point. Now let's assume, so the A and C or A and D, these 1 and 3 ohm resistances are in parallel. So the equivalent resistance of these 1 ohm and 3 ohm resistances, when two resistances are in parallel, then we can get 1 into 3 divided by 1 plus 3, that is 1 by R equal to 1 by R1 plus 1 by R2. So this is equal to 3 by 4 ohm. So the equivalent of 1 ohm and 3 ohm resistances is 3 by 4 ohm, and 2 ohm and 4 ohm resistances are also in parallel, because VCB is equal to VDB, because C and D point are at the same potential. So the equivalent of 2 and 4 is 2 into 4, that is 8, divided by 2 plus 4 is 6. So 2 times 3 is 6, that is 4 by 3 ohm. So the total resistance, that is 3 by 4 ohm and 4 by 3 ohm, are in series. So the total resistance of the circuit is 3 by 4 plus 4 by 3. So 12 is the LCM. So 9 plus 16. So this is 25 divided by 12 ohm. So the total resistance of the circuit is 25 by 12 ohm. So the current is, the total current of the circuit, that is I is equal to V by R. So V is 50 and resistance is 25 divided by 12. So this is 25 into 250. So 24 ampere. So the current flowing in the circuit, each total current is 24 ampere. Now this current 24 ampere will divide it into two parts. Let's say through this branch I1, and through 3 ohm resistance it is I2. Now 24 ampere is I1 plus I2 is 24. So I1 plus I2 is 24 ampere, because 24, if we apply the Kirchhoff's current law at this junction, that is at the point A, so at the point A, then I1 plus I2 is 24. Now we know that the potential difference between A and C and A and D are same. So the potential difference through 1 ohm resistance is current into resistance, that is I1 into 1 is equal to the potential difference between A and D. So A and D, the resistance is 3 ohm and current is I2. So 3 into I2. So I1 is equal to 3 I2. Now put the value of I1 here, that is 3 I2 plus I2 is equal to 24, or 4 I2 is equal to 24. So I2 is equal to 6 ampere. So we get I2, this is 6 ampere. So I2 is 6 ampere. So I1 is 24 minus 6, that is 18 ampere. So I1 is 18 ampere. Now we get the current through 1 ohm resistor is 18 ampere, and through 3 ohm resistor it is 6 ampere. Now similarly we will find the total current through 2 ohm and 4 ohm resistor. Now let's assume through 2 ohm resistance the current is I1 dashed, and through 4 ohm resistor the current is I2 dash. So I1 dash plus I2 dash is again 24 ampere. So the total current will be flowing through the battery is 24 ampere. So I1 dash plus I2 dash is 24 ampere. That is I1 dashed plus I2 dashed is equal to 24 ampere. Now calculate the potential difference between C and D. So the potential difference between C and D is current into resistance. So current is I1 dash and resistance is 2. So 2 I1 dash is equal to the potential difference between D and B, because C and D point are at the same potential. So the potential difference between CB and DB are same. So the potential difference between DB, that is current into resistance, that is 4 I2 dashed. Now 2 cancels, that is 2 into 2 is 4. So I1 dash is equal to 2 I2 dash. So I1 dashed is equal to 2 I2 dash. Now put the value of I1 dash here. So 2 I2 dashed plus I2 dashed is equal to 24. So 2I2 dash plus I2, that is 3I2. So 3I2 dash is equal to 24. So I2 dash is 24 by 3. This is 8 ampere. So we get I2 dash. So I2 dash is 8 ampere. So current is 8 ampere. So I1 dash is 24 minus 8, that is 16 ampere. Now if we apply the Kirchhoff's current law at point C, then the current coming at point C is 18 ampere. So if we apply the Kirchhoff's current law at C, that is the current entering the point C is 18 ampere and leaving is I1 dash, that is 16 ampere, plus in the current in the branch CD, let's assume this is ICD. So ICD is equal to 18 minus 16, that is 2 ampere. So the current in the CD branch is 2 ampere. You can find this current by applying Kirchhoff's current law at the point D also, and you will get the same answer, 2 ampere. So the current through the branch CD of the circuit is 2 ampere. Thanks for watching. Please like this video, subscribe my channel and share this video.